Good morning, everyone, and welcome to our Bucher Vaslin North America Lamothe-Abiet webinar. Today, we are going to talk about reducing sulfur in winemaking, focusing on microbial control. So we're going to look at the sulfur alternatives through the entire process of winemaking, from grape harvest to wine aging. My name is Eglantine.chauffour. I'm the winemaking product manager for Bucher Vaslin North America, and I will be your speaker today. So first of all, I would like to introduce you to our two partners for this webinar. Bucher Vaslin, designer, manufacturer, and seller of material for grape and wine processing since 1856. So 162 years of history and knowledge all around the world. LaMotta-Abiet, winemaking product brand, renowned for its high quality and premium products. It has been founded in Bordeaux in 1878. So 140 years of expertise in winemaking consulting, mainly focused in Europe. We are now making it available for you in North America. So this webinar is going to be about half an hour presentation with a 10 minutes question and answer at the end of the presentation. We are going to talk about the alternative to sulfur for microbial control through the entire winemaking process. And if you have any connectivity issue, please go on support.zoom.us. You will find all the answer you need. So SO2 is one of the first additives that has been used in winemaking. It has been used with the Romans when they discovered that burning candle made of sulfur in amphoras was actually preventing wine from turning vinegar. So nowadays, sulfur is still the most important wine additive. It's also one of the most common concerns of winemakers. The reduction of sulfur, it becomes a challenge since a while. Why do we want to reduce sulfur? Because of the consumer concern. Consumer wants more and more natural, allergen-free, organic products. The media is blaming sulfur for the headache caused by the wine, which between you and me is not true. And sulfur is as well a strong allergen. In addition to this, we have to put sulfur on the label so consumer is aware that wine can contain sulfur. The second reason is so that sulfur can have some negative impact on the wine quality. So there is some technical aspect. Sulfur is going to act as a solvent, so it's extracting more compounds, which can be good or bad. It can inactivate thiamine, which is an essential vitamin for the yeast health and the fermentation. Sulfur can bind to free anthocyanin and bleach color. Sulfur can favor the synthesis of H2S by the yeast, but also sulfur lowers the redox potential of the wine, which is creating some off aromas, especially reductive off aromas. And then sulfur has its limits. So it's not always efficient in wine. There is different form of sulfur. When we talk about total sulfur, we are considering the bound sulfur and the free sulfur. It happened that the bound sulfur is completely inactive. There is no action of this sulfur as antimicrobial, antioxidant, or antioxidasic. So the idea, if we are in a reduction of sulfur, is to limit the amount of molecules that can bind sulfur, which are acetaldehyde, pyruvic acid, oxoglutaric acid, diacetyl, and so on. These compounds can be created by yeast or bacteria when they are stressed, but also when the grapes, by oxidation, or if the grapes are contaminated with botrytis. The other part of sulfur that is important is the free sulfur. And since today we are talking about antimicrobial, I would like to focus your attention on the molecular sulfur, which is the only one that has an antimicrobial effect. Molecular sulfur is depending on free sulfur and pH, as you can see in this graph. So if we are taking an example of red wine with a 3.8 of pH, you would need 80 milligram per liter of free sulfur in the wine to get to 0.8 milligram per liter of molecular sulfur, which is the amount of molecular sulfur that has an antimicrobial effect. 80. This number is completely aberrant, not coherent. and this number will not happen. This doesn't make sense. I would never recommend to age a wine with 80 milligrams per liter of free sulfur. The wine will be completely bleached, will completely smell reduced and sulfur, and will not move. Nothing will happen. So basically, where I'm going with this graph is that using sulfur as an antimicrobial doesn't work in every wine. When we are talking about high pH wine, free sulfur, free sulfur is not enough, is not an option to have enough molecular sulfur to have an antimicrobial effect. So the thing is that even with its limitations, finding alternative to sulfur has been a challenge for researcher and winemaker since a long time. Sulfur is a simple molecule that is very easy to find, and it is a multitask agent. So if we start to look at the entire winemaking process, let's start with grape and mast protection. Sulfur can have an action as extraction, antioxidant, antioxidasic, and antiseptic. We can have alternative for each actions, which would be different. Extraction, we can use maceration enzyme. Antioxidant, we can use sacrificial tannins and sulfur peptides, such as glutathione or cysteine, and we can use ascorbic acid too. Antioxidasic tannins, some tannins are very efficient against lacase and polyphenol oxidase and finding agents such as bentonite. Antiseptic, we are going to talk about microbial competition, ketosane, or other antimicrobial agents that can exist on the market. So today we are going to focus on the antiseptic, antimicrobial part, action of the sulfur, which I would like to go with. The first step to make wine without sulfur is to actually work with good grape quality. So sorting the grapes is a very important point. And the second point is hygiene. Make sure the cleaning and sanitation procedures are actually well established and well controlled. So if we look at the sorting options, working with good quality grapes is going to be very important. You can use sorting tables, vibrating, manual or mechanical. They can go up to 25 tons an hour with some people on the table to help you sorting. Optical sorting, so Bucher Vaslin has the Vistalis, which is sorting with an extreme accuracy that you can adapt to the objective and the initial quality of the grapes. This is a bit slower. We go up to 10 tons per hour. And then densimetric sorting, so making a density bath with separating the grapes by maturity, density, but also removing the grapes that are open or contaminated. This type of instrument or equipment will run from 4 to 6 tons an hour. It's also possible to wash the grapes and the full clusters with this equipment. So just to let you know, the Densilis is in California now, and we are actually making live demo in Napa and Paso for this season. You can have more information on sorting option in our website that you can see below, and also some videos of how this machine works on our YouTube channel. So once grapes are harvested, maybe washed and sorted, we have several options. We can work with Lysozyme or ketosane. They can be good approaches that we will talk about actually later in the presentation for wine aging. And we can have as well microbial competition and bioprotection. That's where I would like to focus today. Implanting and managing positive microbial flora to reduce the presence and the development of unwanted microbes is a technique that has been used since ancient time and in many industries, such as medical, pharmaceutical, food, even vineyard management. So, and basically by using a bioprotection or a positive microbes, we are not eliminating the unwanted microorganisms, we are just inhibiting them, which makes us able to keep or restore the balance and a healthy equilibrium of microbes. So we are not destroying the natural microbes, we are just controlling them with a much more powerful and positive microbe. So bioprotection is a natural way to inhibit unwanted microbial development and wine spoilage. So we are managing microbes by mastering the colonization. Which microbe can we use in winemaking for this type of action? We need microbes that have strong implantations, that are dominant population, that inhibits the other unwanted microbes, that does not produce any off flavor and does not ferment. So many studies has been made on bioprotection in winemaking, and the strain that was the most interesting and that is checking all these requirements is called Mechnikovia pulcherrima, that we are going to call MP to make it easier. So why MP? Because it does not ferment, because it has a strong dominance and colonization ability, because it has a good aromatic impact. MP has an important beta-glucosidase activity, which allows this yeast to express more varietal aromas from the wine, from the grapes. And MP is producing pulcherrimine. Pulcherrimine is a brown pigment, as you can see in this plate, the picture of the plate here. That has an antimicrobial effect. So that's how MP can actually be used as bioprotection. She is producing a lot of pulcherrimine that are just inhibiting the other microbes without killing them. LaMothe-Abiet worked with universities to isolate specific MP strains, which is excellence by nature. So studies has been carried out by Stellenbosch and Bordeaux universities. We narrow it down to, between all these Mechnikovia pulcherrima strains, we narrow it down to one strain, which is the excellence by nature. And in addition to this point that I told you about, we looked at the fermentation kinetics, which means actually no fermentation, the enzymatic potential, and the production of H2S, VA, and of flavor that has to be low. So now I would like to talk a little bit more about the antifungal activity. So here you can see a table that summarizes different strains of Mechnikovia pulcherrima, and the strain 48 is the excellence by nature. As you can see, they don't all have the same power of inhibition, so we selected the one that has the strongest inhibition on the non-saccharomyces. I would like to bring your attention also to the fact that excellence by nature, or even Mechnikovia pulcherrima, does not inhibit Saccharomyces cerevisiae. Saccharomyces cerevisiae is not sensitive to pulcherrimine. As you can see in this graph here as well, when we inoculate both strains together, Saccharomyces is just going in lag phase and then start to ferment. Mechnikovia pulcherrima will start to die after a few days of fermentation because there is alcohol, and this strain is very sensitive to alcohol. So if we look at a summary of excellence by nature, it is a pure Mechnikovia pulcherrima. It does not produce H2S or volatile acidity. It has a POF negative, which means that it does not have a gene to produce volatile phenol, so you will not produce off aromas with excellence by nature. Strong and fast implantation, strong viability or long viability, ferment up to 3.5% and then it dies. Low production of ethyl acetate. Positive organoleptic impact as its expressed varietal characteristic. Strong resistance to sulfur, up to 50 ppm. Wide range of temperature. Good resistance to pH, and a very strong antifungal activities as you saw previously. So, and obviously, what I would like to add to this is that this yeast is certified organic. So now let's go a little bit more practical and talk about how to apply this yeast in winemaking. First of all, you can add it on for white or red grapes. You can use it for grape transportation. You can use it for juice transportation. If you don't want to put too much sulfur, but you still don't want to be managing microbial spoilage, you can use Mechnikovia at this moment. You want to use it as early as possible. So in the harvest bin, in the harvest machine, at tank filling, pressing, there is no problem to use it on white. Since this yeast does not ferment, you will still be able to settle your tank very well and clarify it with no problem. It's a powder, so you can sprinkle the powder directly on the grapes or in the juice with no problem. But also you can rehydrate it in a chlorine-free water. Make sure you don't use too hot water. 25 Celsius would be the optimal temperature. Excellence Bio Nature can maintain its viability up to 4 hours in rehydration. So if you do rehydrate the yeast, there is no problem in leaving the yeast for a long extended period of time in the water, up to 4 hours. So you can prepare it the morning, you use it the full morning on your grapes, and then you make a fresh batch for the afternoon. So as you can see in this graph, this is the viability of the yeast. After 4 hours, we are still having a very good viability. Then after 8 hours, we start to lose a little bit. The dosage of application is going to be 5 to 10 grams per hectoliters, depending the grape condition. And the last point is that Excellence Bio Nature is not using YAN, so it does not reduce the YAN for the yeast, so there is no competition at all with Saccharomyces cerevisiae, and you don't need extra nutrients. Okay, so now that we know how to use it, I would like to show you some trial results that has been done on Cabernet Sauvignon and Chenin Blanc. I choose to look only at the tasting results, as it is the most important result when we are talking about wine and we are making wine. So at the end, what we want to know is, do we have a difference in terms of tasting? So you can see here the result of the Cabernet Sauvignon. So we are comparing a tank with normal sulfur addition, a tank with 0 sulfur addition and inoculated with Excellence DS, and the tank in brown or in green with Bio Nature and sulfur addition, and Excellence DS with no sulfur addition. Very interesting that you can see the brown or green, which is a Bio Nature, has been much more appreciated than the one with sulfur, much more aromatic, cleaner, more complex, much less fault, also more balanced and more round, comparing to the tank with sulfur that has been the least favorite. We did the same in Chenin Blanc, and you can see more or less the same result. We have better appreciation with the Bio Nature, more aromas, less fault, and more balanced acidity. So in terms of analysis, just to let you know, the tank with sulfur was having much more sulfur, and the tank with no sulfur and Excellence DS, the tank with Bio Nature and Excellence DS, or the tank with sulfur, were having the same VA and bacteria load as the final wine. So to conclude on Bio Nature and its application on grapes as alternative to sulfur for microbial control, Bio Nature helps to manage the microflora at the first stage of the winemaking process. We can reduce or completely eliminate sulfur on grapes. We are producing less sulfur combining compounds as the yeast is less stressed. There is no sulfur here, so she is producing less acetaldehyde, so she combines less sulfur. So your sulfur is going to be more efficient later during aging. We have more aromatic and mouthfeel complexity, as you saw previously. And also, it's a yeast that is organic certified, non-allergenic, so it's a good alternative to sulfur for microbial control. Okay, so this was for the grape protection. Now I would like to go back to the winemaking process and speak a little bit about when the wine is fermented. So when the wine is fermented, is becoming wine, we have less microbes to control, and sulfur is used for different actions. So we have other tools. The actions of sulfur are antioxidant, antiseptic. Antioxidant, again, we have the tannins, ascorbic acid, and sulfur peptides, such as glutathione and cysteine. Antiseptic, we have microbial competition and ketosane or other antimicrobial agents. We are going to focus on this part for now. Something very important to consider, again, is hygiene, and make sure you are having a good cleaning and sanitation procedure set up in the winery. Then, when we talk about microbial competition during alcoholic fermentation and malolactic fermentation, it is important to know and control the dominant strains. This will help managing contamination and spoilage microbes. So during alcoholic fermentation, obviously good fermentation management with yeast nutrition to avoid stack fermentation. This is essential. And inoculating with a commercial yeast is going to be a comfort and a security. When we talk about malolactic fermentation, inoculating with malolactic bacteria is even more important. Lactic acid bacteria can be responsible for most of the spoilage microbes, most of the microbial spoilage in wine, during aging. So very important to control the development of bacteria and which one is going to be dominant. So if we consider the malolactic bacteria inoculation, we can actually make the analogy with bioprotection as well. So after alcoholic fermentation, we are in warm condition with some nutrients and substrates such as malic acid, no competition. We are in a microbial vacuum at this moment and low protection. This is perfect for contamination. And usually Lactobacillus, Pediococcus, or Brettanomyces are the most dominant. They love this environment and they start to take over. And it becomes not under control. Using a malolactic bacteria at this stage is going to help you colonize the environment by a strain that you know is positive and will do the job better than the wild one. So we can consider it as bioprotection. So it's going to help you control the microflora balance, limit the risk of spoilage microbes contamination as you are putting dominant strains that you know. So this contamination doesn't happen. You secure your malolactic fermentation, you limit the biogenic amine production since you limit the lactobacillus or pediococcus development, limit production of SO2 combining molecule. As we limit oxidation, we limit spoilage, but also we limit off aromas production. As I was telling you, lactic acid bacteria are responsible for all the most common fault found in wine. They can produce volatile phenol precursors that Brettanomyces will use to produce Brettanomyces stains, such as horsey, barnyard, pharmaceutical type of aromas. Mousiness, they can produce mousiness, that is an aftertaste in the wine that tastes like a dead mouse, of mouse urine, makes the wine completely undrinkable and very hard to remove from the wine. Biogenic amines, we just talked about it. In addition to the legal aspect and the cancerogen, allergenic characteristic of some biogenic amines, they also are associated to off flavors such as rotten flesh, fish food, stagnant water, algae, pond. You can have some uncontrolled production of diacetyl, which will combine with sulfur, but also will make your wine taste like a very fake, buttery, rancid character. And then you create VA and other common aromas that are unpleasant in the wine. So very important to don't leave malolactic bacteria get wild and to control it. Using commercial strains and inoculating your wine for malolactic fermentation will allow you to control the malolactic fermentation and make sure you don't have to use sulfur to kill spoilage. So LaMotha-Abiet bacteria that would be recommended for any difficult condition is NO1. It's a bacteria that has been isolated for its resistance to difficult condition with a high survival rate, short lag phase, and fast malolactic fermentation. It's not producing biogenic amines, no harmful metabolism. It consumes acetaldehyde, so it allows you to have lower sulfur combining molecule, and it's a low diacetyl production. You can use it anytime, early or late co-inoculation, sequential inoculation, curative inoculation, as it is a resistance to difficult condition. And also you can add it directly into your wine, or you can rehydrate it if you want. So once malolactic fermentation is done, we start to have other options as alternative to sulfur for antimicrobial agents. We have lysozyme. Lysozyme is a protein that is extracted from egg white, so it is allergen and it is gonna react with color as it is a protein, so you remove color in red wine. It is requiring more bentonite in white wine to stabilize for protein. And lysozyme is very efficient, but only on lactic acid bacteria. Then we have chitosan, which has a wide spectrum of antimicrobial activity, so lactic acid bacteria, but also Brettanomyces, acetic acid bacteria, and some non-saccharomyces yeast. We are going to focus on these compounds today. Filtration is possible, more pre-bottling, to just remove any spoilage. And DMDC, which is Velcorin. Velcorin is active mainly against yeast, not so much against bacteria. So we are talking mainly about Brettanomyces. Again, at this step, hygiene and cleaning, sanitation is your best friend. So if we focus on chitosan, chitosan is a deacetylation of chitin, polysaccharide derived from Aspergillus niger. So you can see here a molecule of chitin that we are removing the acetyl group. We are putting them in acid environment, and then we get some charged polysaccharide, positively charged polysaccharides that are actually very reactive. So how it works? There is a charge attraction between chitosan that is positive and the microbe cell walls that are negatively charged. As you can see in the picture on the back side of your screen, the cells get trapped into chitosan, and as a magnet, they attract each other as a magnet, they get trapped, and then the cell walls get alterated, and the cell is gonna die. So basically, chitosan is a fining agent that is not completely soluble in wine, so you will have to rack it from your tank. You will do a treatment and then you rack your wine from the microbes. But it is vegan and allergen-free. It's controlling malolactic fermentation. It can remove spoilage microbes. It can prevent spoilage. If we use it as prevention, we are going to use it at 2 grams per hectoliter. If we use it to remove a contamination, we are talking about 4 to 6 grams per liter. The dosage I'm giving you are for the Kilbret, which is the LaMotta-Abiet chitosan. It's a 100% pure chitosan. To look a little bit more at the application, again, at curative, I said you can use, you have the dosage here, but from 2 to 8 grams per hectoliters, depending the contamination. But if we are talking about prevention, which means you are going to add the chitosan into your wine while you suppose maybe you have some microbes, but you probably don't, but you don't want them to develop, so you're going to kill whatever is there. This chitosan is going to still be active. This Kilbret is going to be active for 4 months after the treatment. We realize that if there is a recontamination of the wine that has been treated with chitosan, and the chitosan is still there, the development of the population is going to be very low. So chitosan is still active. Then another thing is that we realize that chitosan, so in addition to be still active, even if the contamination is high and there is still some Brettanomyces alive, Brettanomyces cells, chitosan will affect the metabolism of Brettanomyces and will actually impact the enzymatic activity, and will reduce the production of volatile phenols. So the Brettanomyces will not taint the wine as much. Again, we are talking about very low dosage with the Kilbret, so there is a very limited impact on the organoleptic profile. So before making the conclusion on this alternative to sulfur for microbial control, I would like to go on one important point, which is if you want to use sulfur but you just want to reduce the dosage, one very important thing to keep in mind is to actually reduce the production of molecule combining sulfur, so your sulfur stay active as much as you can. For this, you can eliminate completely sulfur on harvest, since this sulfur will end up anyway total, bonded, and we have a very good alternative, which is Excellence Bio Nature. Then you want to make sure you have enough thiamine and you are not lacking on thiamine for the yeast, so the yeast can develop healthy and will not produce molecule combining sulfur. You want to choose a yeast with a low sulfur production and a low acetaldehyde production. You can favor co-inoculation. Co-inoculation show very good results in limiting the production of molecule combining sulfur. Our next webinar will be on this topic, so I strongly invite you to come and attend. And if you choose bacteria that consume acetaldehyde, it's better. So NO1 is a bacteria that can consume acetaldehyde, so reduce the combination of sulfur. And then when you do your first addition of sulfur, please delay it from few days after malolactic fermentation. You will see you will combine much less. So to conclude on our full winemaking process, alternative to sulfur would be sorting, work with great quality fruit and sort the fruit. And then you can use Excellence Bio Nature instead of sulfur as antimicrobial control. Then you are gonna inoculate your wine with yeast for the alcoholic fermentation. You are gonna inoculate your wine with malolactic bacteria for malolactic fermentation. As soon as this one is done, you can eliminate gross lees and you can start managing microbes with Kilbret, which is a ketosane agent that will have a wide spectrum of antimicrobial. So basically, wine without sulfur is not impossible at all. You have to be very rigorous and know exactly what you are doing, but it's something very doable. Today we focused on microbial control. Next time we will focus on antioxidant control, and think that this idea is also to reduce the dosage of sulfur, not only removing it. But as you can see here, it's not completely undoable. So I would like to thank you very much for your attention. We will now do the question and answer portion, but before this, if you have any question and if you want to send me an email, my email is below, eglantine.chauffour@buchervaslin.com. You can visit our website as well. This video will be on YouTube, so you can rewatch it anytime you want. And now I'm ready for your question and answer.